Jette Rauha is talking about emerging hardware and how that can drive software innovation. So let's give Jette a big hand for being here today.
Okay. Thank you very much. So let's talk about how would you want to use hardware or software, like the new stuff which is on its path to becoming a mainstream thing. How you would use that for inspiration for maybe demos or games? And maybe first a few words about myself. I have like 14 years of professional experience in IT and games, and like 20 years of experience in demo scenes. Okay, so what we are going to talk about today is why is some kind of motivation, like intrinsic and extrinsic motivation for finding inspiration from new stuff, like what is normally something that some people are just working in their basement, but not like a hot thing yet for a mainstream. And how would you find something new or novelty but applied to the current day from that kind of hardware or software? And a few examples or case studies, and also some tips for approaching development. So I had looked at what actually the emerging means from the newcomer dictionary from Merriam-Webster. So you see there, it's like newly created or noticed, and growing strength or popularity, but it's not yet mainstream. It means becoming widely known or established. So then next, let's think about some motivation. Why? So like learning new stuff is fun. Okay, some of you may not agree on that if you're still in school learning some subject you're not that into it. But learning stuff is fun in a way that it's true when it's something interesting, if you do it like just because you want to do it. And that is something which can be thought of like intrinsic motivation, because it comes from inside you, it's not forced on you anyway. And about the degree of novelty, well, why something is interesting, we could ask. And perhaps you think of doing something like nobody has done before. And that's a very, very valid reason. However, for emerging technology, that's also kind of oxymoron, because emerging means it's already growing in popularity, so it's against some of it. So there's a path, but there's already 100 or 1,000 people who already went that way. But that is fine, since they are the early adapters, like adopters like you, and that is also encouraging in a way, because like you and those people make the community for the thing you are working with. So that actually makes things easier for you. But still, it's still like a new path, so it's an exciting adventure to work on something new. And if you compare, like go on to the analogy to paths, then it's not like a highway for millions. It's still a new path. We are going like an adventure. Also, if you think about doing something new, then your audience is probably more likely to respond well if you do something which is really new in some way. And overall, it can be even something relatively simple in terms of technology or content or the way you made it. So let's think about how would you find novelty if it's kind of maybe you're out of ideas or something. So you can actively look for opportunities for making new stuff. So first, let's think about point of view. It's a good idea to embrace looking things from different kinds of point of views. Maybe from like consumer or producer perspective, but you can invent different ways yourself as well. And it's okay if something like a hardware gadget or a piece of software or whatever, if it appears lame or very lacking, if it's cool for the other kind of group. For example, let's think about the Raspberry Pi, the little computer for hackers. Like, it's a very lame device for an average consumer. It's barely like comparable to a cell phone, but you can't really do anything like you can do on cell phone. But for a hobbyist builder, it's very cool and cheap because it's easily extendable. Or if you think about some prototype software, it may be incredibly hard to use and make stuff with. So it's kind of lame for the producer. But if it enables you to produce something really cool and new in some way, then consumers will appreciate it, and it pays off to do hard work with lame kind of software for the producer. Then we can think about reframing. Not every part of what you make needs to be new and shiny. So you can look to combine new kinds of devices, data or signals to something old. It can be even digital or analog, which is like already some kind of standard way of doing. So like it's like an everyday thing. So you don't question at all any kind of aspects from it. How do you use it? How do you use a telephone? How do you use a phone? Or how do you play guitar or anything like it's very common knowledge. So try to be creative how you utilize something. So use like an old thing for some and combine that with like a new thing. So and also think about misusing things in a way that you use for something else that software was already originally meant for, or a hardware or gadget or something. And also, when you are trying to find some novelty from stuff, then you could also have like checklist questions. So I have 2 here, but you can think of your own as well, what is kind of an important aspect for you. So for what I'm thinking is like finding novelty is the first one. Does this thing, is it a piece of hardware or software? Does this do an interesting transformation of data? If you put in something, what do you get out? Is it helpful somehow, or delightfully unexpected some way? Or maybe it just automates a lot of manual labor. Also, it's a good idea to think about something which gives you leverage. So the second question is like, what standards does this thing use? Standards allow you to leverage other things like a piece of software, like ready-made software or protocol or connectors or whatever. And you don't have to build every piece of the puzzle yourself to make something new. So next we are going to look at a few examples and case studies. And some of these are from a personal experience. And we'll also think about those checklist questions I just showed you for each one. So first one is like we think about leveraging standards. This is I wanted to take this example because like you could think at what place do boring standards have with new and experimental things. And I wanted to show you an example why it could be relevant, because usually standards is something which is like a lot of work and a lot of specs and paper, and you don't want to look at any way that stuff if you're making like quick progress with something and something new. But there's a place for standards as well. So let's talk about Open Sound Control, OSC. It's a format for passing miscellaneous device data, for example, like performance attributes of a musical performer. And it's not exactly a new thing anymore. One could say that the OSC is kind of emerging standard. But at least it's still a good example of a synergy of software and hardware and the power of having some kind of standards. I have used the OSC for a few game prototypes. One made using the processing language like the Java-based IDE. It's very quick to work with. And software and formats like this allow you to cut corners some ways, so you can make a quick iteration on some first idea you can get. So, for example, instead of doing the hassle of setting up a development environment for your phone or maybe iPhone, and writing your own software to read your phone accelerometers and all that hassle, you may be able to just pick an app somebody else made, which reads the data and feeds over the network. So you get some leverage out of that. And actually, for example, I'm using that in these slides. So I have a phone here, and this phone rotation is directly mapped to the tuba here. And this is something which was really easy to build because I just took the MR application out of the App Store and made an ad hoc connection to my laptop. And I built the slides using Unity, and just picked up a library from the Unity forums to do the connection from the Unity side, and just very little amount of code to actually bind together the protocol and the accelerometer data and put something there. And I'm also using that to switch the slides. So I have a custom interface here just for the previous and next buttons, and this touch area here is like I can do the laser pointer kind of thing. So it's a very simple thing that it's easy to build things like this. But also you might, in this case, you could have used the Unity remote, but I'm actually talking about the OSC here. So you can build the same thing for your favorite framework. It could be the processing, or you could work in the Visual Studio, maybe using open frameworks. And there's open source libraries for this. So it's very easy to use this kind of stuff. And these make you leverage like what you do have sensors on your phone or whatever. Okay, then let's go on. Next I'm going to talk about the demo we made 2 years ago. 2 or 3 years ago, Autodesk Labs released an interesting project called Project Photofly. It's a software which turns a pile of photos to a detailed 3D model. So this is an example how you would use emerging software in the beta or alpha testing phase to get inspiration for something. So if you think about the checklist questions, it's like, does this do an interesting data transformation, or is it new some way? Of course it is, because it's like you have a standard digital camera, you take a bunch of photos from different angles, and that alone allows you to have a 3D scanner which makes a pretty interesting detailed models. And for the standards and leverage point of view, the software exports to standard 3D model formats. So it's very easy to get working on it, integrate your demo art pipeline or something. So when we worked with this, we figured out that at best the models and textures ended up being huge with the maximum detail settings. And also, there's many little things you find from working with the new software. In this case, we found out that, of course, it doesn't work at all for reflecting surfaces, because that changes very much how the object looks from different points of view. But if it's ambient kind of light from not too shiny surface, then it's very, very good. So we used to capture, for example, this kind of 3D model of cinnamon bun. And for the demo, we ended up doing some engine customization to support larger models, because we had a lot of content there in the production phase. And also write a timeline editor for the demo. But still, after some optimization and cleanup, the end result wasn't that big after all. But for example, this bun model here, it's about 250,000 faces. But it's just a simple texture. There's no lighting, no anything going around, and still looks pretty fine, because the software the Autodesk software does so great work with how does it make the 3D model and the texture atlases and everything for you already. And they later released it at 123D Catch. It's available even for your iPhone or iPad to take the pictures and make the 3D models. Okay, for next case, we are checking for like a hardware emerging product. About 2 years ago, Wacom announced Inkling. It's a ink pen, so it's something you can just draw on a standard paper. But it still records the strokes to a digital format. So you can give it to also non-technical persons who have drawing skills and a little bit of tutoring. You can actually get digital sketches from them, even in separate layers, because it allows you to switch layer when you are working on something. So for novelty and data transformation, yeah, it's pretty interesting because it turns analog hand drawings into digital sketches. And for standards leverage, the Wacom tool was kind of, I first noticed, okay, it exports to SVG, this is very fun. But that was actually not very useful, because the data what they collect from the pen, it has, for each point in the stroke, it has detailed pressure and angle information of the pen. And when you export to SVG, you lose all that information. So it just ended up in a field path, which is like the shape, yeah, but the tilt and pressure is part of the shape and burned like there, and you don't get the metadata anymore. So I ended up writing an own tool to use the original data. Luckily, the intermediate format was something which was very easy to read and just look at what the data is and then make an own data for the demo pipeline. And we used this in last year in assembly in a demo by Rust Bloom. And, but it's not the first time of having sketches in demos. Like Armada did the Lineage in 2008. It has a 3D sketch made also with custom software by Lance of Agerson. And Psychic Link did the paper intro in 1996. It was actually not recorded sketches, but it was very convincing look. Anyway. Okay. Then continue to a hardware theme, thinking about hardware hacks. If you want to go more hands-on, so to say, you may have to learn some electronics, for example. And Arduino is good and easy for simple electronics things, like if you want to drive a board of LED lights or motors. And the Raspberry Pi here it's kind of more interesting if you are like a software person, like I am, because it's like a computer and you can run Linux on it and all that. And power-wise, it's comparable to a cell phone, like it's almost a gigahertz CPU and it has OpenGL ES 2.0 graphics. But it's built for hacking. And if you think about the novelty and data transformation point for this, it's more like it's up to you in this case, because this is like enabler. This is only a means for achieving something if you think about what you could combine this with. And the standard leverage thing, it's in many facets offers leverages, because it's a standard Linux for software side, or you can also use Android, and standard hardware connectors. And actually there's quite many of those, like you can put EdgeSIM display on it, or USB devices, normal networking, or audio jack, or I2C for other kinds of hardware electronics component devices. So you just imagine the possibilities when you take one of these kind of hacking devices and combine it with those like small portable screen like you use in cell phones, or maybe a web camera, or a game controller. You can actually use the Xbox 360 controller fine with the USB version, fine with one. Or you could put like small portable video projector, or extra sensors like GPS or inertial measurement unit. So if you just take a few of those, and you can imagine new kind of devices you could build and maybe use it for something in content creation, or like on your own little special thing. Continuing with the hardware hacks theme, I want to take one nice example what you can do. My friend Pepe Taskinen built a do-it-yourself Rift, and what is actually meant is, well, like he ordered the parts from the internet and slapped them together, and wrote a bit of software to run the sensor fusion on the Raspberry Pi. and feed that to PC and the 3D engine. Actually, the MTBS 3D forums have instructions for building these kind of things, and it's the same forum where the original Oculus Rift originates from. And it doesn't really take that much. All those components actually have some kind of standard interface, so it's very easy to combine them together if you just think about what's actually possible and just do it. If you have a little bit of budget, the components are actually cheaper than you can imagine. And of course, I want to talk a little bit more of the Oculus Rift as well. We actually made a game for it, for this assembly. So in the game development competition, you maybe saw the Yink game where you have to duck trees like this. And that is one of our prototypes for trying out what is to make gameplay with Oculus Rift. And one could argue that this is maybe the hottest recent technology, and it truly enables new kinds of experiences. But basically that means also that very simple things are something which become a new experience. And as a developer, you have to stop actually doing something which you are used to doing beforehand, maybe some fancy special effects, which have been the norm to do until now. To take some example, like many games do heavy exaggeration in special effects, maybe to tweak the field of vision in car games, or whatever, like camera shaking. And in VR, stuff like that make actually people sick. So it's very much like a new area of experimentation, and you have to try it all, and you actually yourself you get used to all the weird stuff. So you have to have a fresh set of people flowing in and trying out. So you have basically it's a good idea to stick with the basic stuff first. But the good news is like that in VR the sense of scale is so very different from what you see in a cell phone screen or even your big monitor. It's like you can feel that something is like here. So imagine if you're standing next to a building in a game, and it doesn't sound much, but if you compare it from when you're playing on a monitor, then even that is a new experience in VR. Because in VR you have to go around and even like lean back to actually look up and figure out the scale of the house. And it actually feels big in that way. So for novelty and transformation points, of course, it's very new because it turns like a standard 3D engine and some sensor data to virtual reality. So it's very huge leap and quite exciting one. And for the leverage and standards point of, the Oculus uses like standards like USB connecting and HDMI to put in on your PC, but actually it's more like this is something of defining a new standard, and they are actually making it very easy to get integrated in the game engines. Like for example, Unity, it's all like drag and drop, and you can also have a scene and play with it as a developer. So finally, also some tips for approaching development. Maybe mostly for newcomers if you haven't done any exploratory development yet. If you get enthusiastic about some new thing, you probably end up with lots of ideas, and some are simple ones, but some are grandiose or complex ones. And it's a good idea to start with the simplest possible ones and go on by small steps. It's easier to identify the weird problems this way and do like course correction to your plans, because you have only small increments and it's easy to reject something and try something new. And also use some base code or framework you know well, or learn one, like a prototyping environment, which makes doing various tests easy and painless and very rapid. So once I have tried it, like Unity 3D and open frameworks and processing. Also, like treat your initial stuff like that is throwaway code. You're free to copy paste, fork, hack, hard code, borrow others' code. Just do whatever you need, because you can always just rewrite the good bits later. And also accept failures. Even if something works, it can be just boring and not very cool after all. Or if you think it's cool, maybe somebody else thinks that it's not. But it's okay, because you usually learn a lot this way, and the stuff you learn you can probably use in the future in some other project, and then it's actually suddenly very relevant. So to recap, like in 5 steps, when you're thinking about using your new thing, play around with it before writing code. So do test with the other tools you might find. And second, check out the file or data formats. Identify pieces you're interested in, those side. 3, find some ready-made tools for leverage if you can. And if not, then write some crude code to do format conversion or whatever. So embrace standards when it gives you extra leverage, so you can skip building one piece of the puzzle. 4, make the first own throwaway for the prototypes, and 5, tweak those, make variations, a lot of them, so you can try out different stuff. And now, bang, you have a working reference code for something else, which you can rewrite for like a production quality stuff. Okay. So I think that's most of what I was going to speak about today. It was just like an inspirational scratch, and I hope you pick up some new next thing you might want to work with. There are many other cool things like Kinect and or Leap Motion, and a lot of those are just waiting that somebody invents a good way to use them and utilize them in cool ways, because it's only like a piece of hardware that gives you interesting signals, but mostly it's about the creativity, what you do afterwards with the signals the hardware gives you. And remember the novelty and data transformation angle and standards and leverage. Okay. Thank you. Do anyone have any questions? Feel free. If you want to ask in Finnish, it's also okay. I can translate to English for the stream. Okay. If not, then I thank you. Thanks for coming.